Guys, we were discussing about the safe speed. So I have just pasted a notes which I have prepared on my own. So if you are worried about the notes or study material, don't worry about it. I have prepared a study material related to the geometric design of the track, which I will be giving today or tomorrow. Don't worry about the study materials. You will get the study materials on time. So we were talking about the safe speed of the train on the curved tracks. So in order to derive the safe speed, what would be the safe speed for a train to travel along a curve? In India, the following formulas are given by Martin, were generally employed to work out empirically the safe speed on the curves, where the transition curve exists. If the transition curve exists, that is no transition curves. If there is no, if a transition curve exists, or on a transition curve for a broad gauge or a meter gauge, the safe speed v in kilometer per hour is given by v is equal to 4.35 square root of r minus 67, or v is equal to 4.4 square root of r minus 70. This I have considered as equation A. Now for a narrow gauge, for broad gauge and meter gauge tracks, this is the safe speed. This is how we are going to get the safe speed while traveling along a curve, which consists of a transition curve, for a narrow gauge track. For a narrow gauge track, v is equal to 3.6 square root of r minus 6.1, or v is equal to 3.65 square root of r minus 6, subjected to the maximum of 50 kilometers per hour, where the transition curves are absent. That is, on non-transition curves for broad gauge and meter gauge tracks, v is equal to 4.4 by 5 4/5 of the speed calculated in the figure or in the equation A. Yeah, that is, on a non-transition curves, the above speed is reduced by 20%, right? So when a transition curve exists, what happens? The speed of the train is given by this formula. When there is no transition curve, the speed of the train is reduced by 20%. This is how we are going to calculate the speed of the train for meter gauge, broad gauge and narrow gauge tracks. So moving on, for narrow gauge track, 4/5 of the speed calculated in B, that is v is equal to 2.92 square root of r minus 6, subject to the maximum of 40 kmph. For high speeds, generally the following empirical formulas are used. V is equal to 4.58 square root of r, where v is equal to speed in kilometers per hour, r is equal to radius of the curve in meters. The maximum speed for transition curve is now determined on Indian Railways as per the revised formula given below. On broad gauge tracks, v is equal to CA plus CD into R divided by 13.76, or V is equal to 0.27 CA plus CD into R, where V is equal to maximum speed in kmph, CA is equal to actual cant in mm, CD is equal to cant efficiency permitted in mm, R is equal to radius in meters. So coming to what is a cant and what is cant deficiency, this we are going to study in next slides or upcoming slides. Here cant is nothing but the super elevation which we are going to give on railway tracks. You already know that concept. We will discuss that in brief in the next upcoming slides. On broad gauge tracks, V is equal to 0.347 CA plus CD R. On a narrow gauge tracks, V is equal to 3.65 square root of r minus 6, subject to maximum speed of 50 kmph, right? These are some of the formulas we are going to apply in order to calculate the safe speed of the train on the curved tracks, right?